Hello and welcome to the best practices in data cleaning using OpenRefine lesson as part of the computational research skills series. My name is Alex Nenadic and I'll give you a short introduction on why we are teaching you this and what you will be doing today. Before we move on, a couple of links and acknowledgements. So the lesson material that you will be using today is linked at the top of the slide, and it is based on the data cleaning using OpenRefine from the data carpentry curriculum. Now, data carpentry is part of the bigger international community called the Carpentries. The Carpentries are teaching researchers foundational computational and data skills through a set of different lesson organizations and by running 2-day hands-on and practical workshops. So we have data carpentry that focuses on giving people computational skills to handle their data throughout its life cycle using R or Python. We also have software carpentry, which teaches people automating repetitive tasks, programming using R or Python, and version controlling your code and data. And we also have library carpentry that teaches these foundational skills to people in information and library roles. There is also HPC carpentry, high performance computing carpentry, which is not an official lesson organizations of the carpentries. However, they are working closely with the carpentries community and they are delivering lessons in a similar format and with the similar ethos. So if you attended the best practices in data organization using spreadsheets lesson before this one, you may recall this diagram representing a typical data journey where you start from your research question and then you want to make at the end an informed decision as to whether your research hypothesis was correct or not based on the data that you have available. We are now in the second step of this journey. That is, we have some data. However, we did not have control over data collection step, so we inherited data that is a bit messy, or perhaps we inherited data from multiple sources, from several researchers, and the data is not really consistent, is not consistently formatted. Or, for example, even if you started from scratch yourself, and even though you had full control over the data, you perhaps may not have gotten the data collection and organization step just right. And in any of these cases, you end up with what we call messy data, which you need to clean a bit or wrangle. So that means to fix errors in data, to reformat the data, to reorganize it in a way that is more suitable for further analysis. So what is OpenRefine? OpenRefine is a Java program that runs on your machine, so it doesn't run over the internet or in the cloud. It's a desktop tool that uses your web browser as a graphical interface. So you do not require internet connection to use this tool, and none of the data or commands that you issue in OpenRefine are set over the internet in the case you're worried about your data privacy. So OpenRefine is very powerful and free tool that can be used to standardize and clean data across your files and can help with reproducibility of your data analysis. OpenRefine is open source, so you can find its source code on GitHub, and it has a large growing community from novices to experts, which are all ready to help and answer your questions. And it can also work with relatively large data sets up to 1 million rows. A bit more on motivation. Why should you use OpenRefine? So data is often very messy, and this tool saves a lot of time on cleaning data. So it can help you get an overview of a data set. It can help you resolve inconsistencies in a data set and detect some errors and outliers in your data. It can help you split data up into more granular parts if that's what you need. It can also enhance a data set with data from other sources. It is also important to know what you did to your data, so the steps that you took when working with your data. With OpenRefine, you can capture all actions applied to your raw data, save them, and then share them with your publication, for example, as supplemental material, or with your colleagues to reuse. OpenRefine also does not modify your original data set. It leaves your raw data intact and works on a copy. And in addition, all your actions are also easily reversible in OpenRefine. Data cleaning steps, data cleaning steps often need repeating with multiple files. And OpenRefine is perfect for speeding up repetitive tasks by replaying previous action on multiple datasets. OpenRefine also implements some very complex concepts and algorithms, such as data clustering, and makes it really easy to use them by end users. The OpenRefine is not the only tool to do data cleaning. You can, for example, write R or Python code to clean your data, and you can repeat those steps by running the code over different data sets. However, OpenRefine has a lot of powerful data cleaning features built in that are not so easily available from R or Python. Plus, you do not need to know how to code to use OpenRefine. So these tools should rather be used in conjunction, and you should always consider using the best tool for the job. So for the setup for this lesson, you will need OpenRefine tool and some messy data as explained in the lesson material. OpenRefine is a Java program, so you will need to have Java installed on your machine too. However, the latest version of OpenRefine, version 3.4, has Java embedded within, so you do not even need a separate Java installation, which makes it very handy. As far as the data used in this lesson, it comes from a project observing a small mammal community in southern Arizona, the US. This is part of a project studying the effects of rodents and ants on the plant community that has been running for almost 40 years. So the rodents are sampled on a series of 24 plots with different experimental manipulations controlling which rodents are allowed to access which plots. So this is a real data set that has been used in over 100 publications. For the purpose of this lesson, however, the original data has been modified and simplified, and also we are using only a subset of the original data. Still, you can download the full data set and work with it using exactly the same tools and steps that you will learn in this lesson. So this simplified teaching version of data is available on Figshare as part of the portal project teaching dataset, but is also linked from the lesson materials. So throughout this lesson, you will work with this data to clean it and get it into a better shape. So here is the outline of the lesson. You're going to learn how to work and explore your data using OpenRefine. So how you can bring the data into OpenRefine, how you can summarize and get a high-level overview of data, how you can find and correct errors as well. Next, you will learn how to filter and sort the data, so you can only work with a subset of your data. You will learn how to work with numeric data, so how to convert one column or column from one data type to another, and how you can visualize relationships among numeric columns. You will learn how to document and save the cleaning steps you've applied to your data and how to apply these steps to additional data sets for reproducibility. Also, you will learn how to export your data, your clean data from OpenRefine for further use by downstream applications. There is so much more to OpenRefine that we can cover in this lesson, so we recommend you keep learning it further. Here are only a subset of useful links and further resources. Obviously, your first point of reference is the OpenRefine website and the OpenRefine wiki that contain loads of documentation and help on using OpenRefine. There is also Using OpenRefine, the book, which is the only book on OpenRefine, and it's a highly recommended read. There are a couple of more resources mentioned here on this slide, and there are many more which you can find by Googling. And with that, I just want to wish everyone good luck with working through the lesson material, and we will see you a bit later for the question and answer session and some discussions.